All right, so this is my assignment number 5. I'm gonna start off CAD. Have my answers done. I just want to actually, I'm not gonna so I think done. Just gonna keep it here for the ease of time. So we're gonna start off with making a nano server C first. We're gonna create a file. I'm gonna upload my code now. Yep. So that's my code uploaded. Now we show. So that was for the server. Now this is for the client one that we make here. So we code for the client. After that, come here. We do last. We have server and client made, and then we're gonna compile both of them. Oops, should not be doing that. Perfect. So now we have it ready. Now we shall run both of them. File exists. And now we're gonna do the client. Connection to server, permission denied, FIFO. So now I'm just gonna p kill. Okay, so now basically now if I go through what happened in this basically, so I started off with work in my directory, 2560 assignment number 5, and then I basically moved to the Linux server. And then basically what happened was, and then I created the server program for question 1, which was server.c. As we seen that, then you seen the code. Now, if I touch back upon the code, I can explain that a little bit here. So basically in server.c, I defined the two FIFO paths. So basically one for the messages and one for the client to the server. And then for acknowledgements, I used the TMP FIFO underscore SC, and that was from the server back to the client. And then I call it MK FIFO, and that's for both names. So the server and client can have basically a two-way communication, as that's what's unique about this specific lab. And then I opened the TMP FIFO underscore CS in read-only mode, and I received the characters from the client, and then TMP FIFO in write-only mode to send acknowledgements. And inside the loop, the server reads one character at a time, prints a character, it receives and writes a string. I received your message back to the client through the second FIFO, and at the end, it closes the file descriptors. And unlike the FIFOs, and then after that, I basically worked on the client C, which was this code over here. And then what happened here was the meaning of this code specific was I basically used the same two FIFO names, so the client matches the server, and the client repeatedly tried to open TMP FIFO underscore CS in write only mode until the server has created it, and then it opens TMP FIFO underscore C in read only mode to receive acknowledgements, and the client reads characters from standard input. From each character, it writes the character to TMP FIFO underscore CS, then reads from TMP FIFO underscore SC until it reaches a new line, like basically acknowledging and buffering and printing it. And this is where the client displays the message, I received your message, then the server sends after each character. And then when I compiled it after that, we basically seen what happened. In the client window, the character that I typed, A and B, for each character the server receives its client, and then it prints the acknowledgement. And then basically after I finish sending the input, I terminate the server process, and basically that was it. So you can basically see that there's a server C and there's a client.c, and yeah, that was basically it for this question. 2 for assignment assignment 5. So I'll get into it. I'm gonna, by the way, I forgot to mention, that's the last one. I have everything done just for the time of ease, so the TA does not have to watch 30 minutes of videos. I have compiled this by keeping everything in my notes and clean. So yeah, so this is question. I'm gonna explain it right after I end up placing everything. I can multitask. Okay, almost done. I'm gonna just compile this boy real quick. You got it ready? Okay, now we're gonna run this. Okay, so now just to get into what this thing is all about is basically we had in class we got this file called basically game.c. We basically I had to rewrite it with the pipe-based game to use FIFOs instead of coordinate the two players with the referee. So basically, now a bit to explain this code, what happens here exactly is that I replaced the four pipes with the four names FIFO. So I defined them as FIFO, TT, in, out. And then I call it MK FIFO. The reason I call it MK FIFO is because on each of them, which satisfies the requirement to make four FIFOs for the game, the referee processes opens each FIFO in the correct mode. So it writes to the end FIFO to send a turn to each player, and then it reads out FIFOs to get the acknowledgement back. And for player Toto and player TT, the player function opens its input FIFO in read-only mode and its output FIFO in write-only mode, and the main loop of the referee still prints referee Toto plays and referee TT plays. It writes a single character to the appropriate FIFO and then reads one character back. Inside player, the dice rolling and score keeping logic is the same as in the pipe version. Each player accumulates points, and when a player reaches and accumulates points, and when like 50 points, it prints a game. So then over I1 steals, and then it kills, and then to terminate all processes, this preserves the original game behavior while they're using FIFO instead of pipes. So then after I compiled it, the game started running, and then which basically produced a executable game as we saw. And then basically when I ran the game, it prints the same introduction as before. It's a two-player game with a referee, and then the referee then alternates between referee Toto plays and referee TT plays. So each time the referee writes to a player's input FIFO, the player reads from its FIFO, it rolls the dice, and then prints points only. Now when one of the player reaches 50 or more points, it prints game over I1 and it sends SIG to the terminal. And yeah, basically that was it for this question. Alrighty, so this is actually my assignment 5, last part about it. I shall get right into it. I'm gonna come to explaining this more towards the end of it. But I'm just going to compile it for right now. So for ease for G watching this. Now I'm going to paste the code here. Perfect. Now we shall compile this boy. Sure, we're ready. Yeah. All right, perfect. So what's basically happening in this question is the concept of this question is basically, actually I'll just explain what happens. So this code right here, it creates a pipe, it closes the read end and installs a sig pipe handler that prints caught the sig pipe signal, and then it writes to the pipe which causes sig pipe and finally prints the right return value and then the error with p error. So basically when I compiled it with the GCC, the output when it came over here, basically, when I run the program, the right trigger sig pipes the message caught the sig pipe signal, and it prints by the handler. The right returns -1, and p error prints the broken pipe error, which basically matches the output required for this question. So then, basically, yeah, that was pretty much it for this question.